Well, hello there again. My name's Pete, and this is EAA with an 8-inch scut. In fact, a Celestron CPC-800, which I won't bother showing again. It's an 8-inch Schmidt-Cassegrain telescope on an altitude azimuth mount, and rather than my eye being sat at the eyepiece outside, we put a camera on it, which is an Altair Astro 294C, and that's actually out there right now. Tonight we're going to observe a couple of solar system objects first of all, I thought. Now what I've done is I've set up this view, which you're seeing right now, of this star field, and this is apparently 18 Melpomene. Well, somewhere in here is 18 Melpomene. If you look over here, we could most probably suss out if we flipped the image, because my telescope flips it, and we can see that this is the asteroid right here, and there appears to be a star over to the left, a star to the right, and then these two stars up here, and that seems to correspond to this section here. So that would suggest that that star there, or that object right there, is 18 Melpomene. Which, if it is, it's an asteroid, a main body asteroid. What's it called? What's it called? Oh, a main belt asteroid, and it is an S-type asteroid, which means it's got silicate and metals in. Apparently, I'm just reading that from Wikipedia for you. 308 million kilometers away from us in the constellation of Virgo. Not stacking at all, just doing a 4-second repeated shot. And what I think I do, if I just take a snapshot of this, because even though I'm pretty sure we know that that little dot right there is in fact an asteroid orbiting between the orbits of Mars and Jupiter, we can make sure, because we have this amazing thing called plate solving, which we've come across before, which I use it when I'm setting up my telescope, aligning the stars first of all, and also for the annotations. Now, it would be great if I could just click on my deep sky image annotations, and it also took care of asteroids. In fact, I think that would be a good feature to have in SharpCap, but it doesn't. So we're going to use another tool called ASTAP to actually do a plate solve on this particular picture we're going to take in a second, and it has the ability to say if there are asteroids. It will actually highlight where there are asteroids or stars and galaxies, a little bit like SharpCap Pro does, but obviously it does it a little bit better because it covers asteroids. So I'm just going to take a snapshot, and there it is. And if I go down into a folder, 23, 12, okay. 23, this one here. Oh, I've made it, so I put it into the M5 Rose cluster for some unknown reason, but that does not matter. So I'm just going to copy this file. It's a fixed file, and I'm going to copy it from the laptop and put it onto my computer here, because that's where ASTAP is running. And then what we're going to do is, if I bring up ASTAP for you and bring it over here, it's the Astrometric Stacking Program and Fits Viewer, ASTAP. And I'm just going to load up the file we've just taken. There it is. Incorrectly named, but we know that's the one I just took. And hopefully it will load up. And there's my image in black and white. If I zoom in a bit and shift it, there I have my two stars up here. My two stars are up here, and my two stars are here. And I have these three stars dotted across, or these, we know that one of them shouldn't be a star. This one in the middle shouldn't be a star. If I solve it, do a plate solve, it solved it in 0.3 seconds. I mean, the FITS file actually hasn't got the position of where the telescope's pointing right now, so it wasn't that hard for it maybe in this particular case. But the great thing about ASTAP is that we can just go into Tools, and I can say Asteroid and Comet Annotation, And I've downloaded from is it the Minor Planets Center, this file here, mpcore.dat, and also the Comet one, just because in a minute we might see a comet, with the latest orbital data in. It's taken this information, the midpoint of the observation, the midpoint of when the picture was taken, and the latitude and longitude of where I am, directly from the FITS file. So if I annotate, immediately you'll see that we were absolutely right, and that Melpomene, 18 Melpomene, was actually the star in the middle of these two here. And that's a great way, I think, just finding asteroids. I mean, I really enjoy finding asteroids, because there's loads of projects I think you can do with it, which I'd like to explore later on. But that was just so easy with EAA. Just take a picture. I mean, go roughly to the area, and even though this particular one is quite bright, it's a magnitude 11.2, you could definitely find asteroids in your pictures using this method. So there we go. I thought that was quite a nice way of seeing an asteroid 308 million kilometers away from us. Let's see what the size of it was. First of all, it was discovered by John Russell Hind in 1852. It's a main belt asteroid, as we said. It has an orbital period of 3.48 years and a diameter. There are several dimensions on this one. We'll go for the mean. It's 141 plus or minus 2 kilometers. And it rotates every 11.5 hours. So there you go. Melpomene, an asteroid. Well, let's leave that. Let's put our little ASTAP back over onto the other screen. And I think what we'll do is we will go somewhere else. I thought we would go and check out, and by the way, I've got Astroplaner up, but this is the Astroplaner beta, and there's a bit of a bug still when it's to Comet, so I'm not going to use this to actually go to the Comet, but I'm going to go and see C2007 K2 PANSTARRS, which is quite a bright comet. So let's just use that just to set. And what we're going to do, if I come out of here and head over, well, actually, I better head over the right direction to, this is Orpheus, is it? Orpheus, yes. And we're looking at Comet K, well, actually in the Planetarium program, we're looking at Comet C2017 K2 PANSTARRS. It says it's not. Sorry, that title is wrong. It's a bug. I can actually show you exactly where it is. There you go. It's in Orpheus here, or Orpheus here. I think we're going to just slew on over. I'm going to fine mode on this. 2 seconds, and let's just stretch it so we can see it. Now this comet is quite bright, so it's magnitude 7.17, and I think we've landed right on it, right there. I'm not 100% sure, but that looks remarkably comet-like. But what we could do, and this seems to be pants stuff now, I haven't done this, that definitely looks like a little fluffy comet right there. Is that what comets look like? Fluffy? No, well, this one looks like a bit fluffy. If I take a snapshot of that one, what we should do actually is we will put into the top the name of it, I think. Oh, that's probably going to cause no amazing amounts of problems of putting a slash into it. I'm just going to say that. There you go, C2007 K2, and I'm going to take a snapshot as a FITS file. And I'm going to go to the folder, and I'm going to copy it. across to my desktop computer, which is sat over here. Its files are quite big. This is 22 megs. Let's get our ASTAP up again. Bring it across. Still got our alpamine there. Let's get let's load up our new one, which is this one. Yeah, look, it looks very very fluffy, doesn't it there? Let's solve it again so we know exactly what every star position on here is. And now let's do an asteroid and comet annotation. And we seem to have a comet. And there we are. Comet C 2007 K2 PANSTARRS. And there it is. So we've confirmed that what we're actually seeing in the middle of our image there is in fact the comet that we're after. So now I'm going to image it now. Now, the problem with comets and asteroids is they move relative to the stars, so we don't want to take too long an image, I suppose. But we've seen a comet, so that's pretty good. This comet's distance from us now currently is 273 million kilometers. So let's do an observe mode. And let's just do a 4 second. We'll try 4 second first, just to... I think we might need longer. Whoa. Oh, have I still got that stretched? Sorry, yeah. That would do it for you. And there's our comet. Right there. I think we can just balance. Wait. Actually, will the keys work tonight? Yeah. If you watched my video from last night, I think I had a serious network issue going on here. Everything got very, very slow, and my keys weren't responding properly, and I was blaming everyone in the world except possibly me for not sorting the problem out, which I should have done at the beginning. I'll bring down the FH and the filter brightness is on. Let's look at the stacking. Yeah. What I'm going to do is I'm going to save exactly as seen on that. Already. 60 seconds, that's all we've got there. And we are now on, let's zoom into PANSTARRS and see what we can see. There does seem to be something around PANSTARRS, and there's the nucleus, I take it, right there. So that's quite impressive. So we've seen an asteroid and we've seen a comet in the space of a couple of minutes, because we have a computerized telescope and we have the necessary tools so that we can identify exactly what we actually see in our field of view. So that, I mean, that's great. I'm very happy with that. Seeing a comet. Let me put that over there somewhere. Let's come back out again. If I leave it out, I'll start to get it will most probably start to elongate. Most probably already is it? This is 308%, by the way, so if we go down to 100%, there's 100%. So again, as most nights, we're not using flats or darks. We're using hot pixel removal, dithering, and I'm dithering every 5 frames. I did a little test before I was coming online because I wanted to go down and see some more stuff in the southern sky in a minute, and it didn't seem to have much of an effect. It still the creeping noise, this kind of noise you get around, disappeared with 5 frames as well. So that means I can do more frames before I have to dither and waste a bit of frames. So it just speeds up the process, which is what we want, I suppose. We go out to 50%. And there we go. We could try and balance it a little bit more, maybe, but I quite liked it as it was. I don't particularly care too much about the light background. It's more that I can see what I want to see. Though by doing that, I have brought up. See, the noise is now very obvious. We'll just boost the red a bit because we're going a bit green, and the blue. I should really go into zoom mode, shouldn't I, and see it? But there you go. A comet. Let's save exactly seeing that's a 3-minute exposure. I'm going to pause it. I think it has moved. I think we've now got, if I zoom in, you can see that it's smeared itself across here because it's moving relative to the stars because it's orbiting the sun. Nice. Another nice EAA experience. So 2 solar system objects, and that is great. Let's come out of here. Oh, well, there's another asteroid over here called 41. Is it Daphne? 41 Daphne. Shall we, just for fun, is that 41 Daphne? Yeah. Okay, so this one's a bit closer. This is 186 million kilometers. Why don't we come out of there and we'll go into fine mode and sorry, let's just change the down to 2 seconds or so, and let's slew over to 41 Daphne, which let me find out a bit about 41 Daphne, having not really. Oh, it's in Wikipedia. Everything's in Wikipedia. So we've got it's a large asteroid from the asteroid belt according to this. Carbonaceous Crondite. Wow. So its orbital period is 1,679 days. Is that right? I got that right. Its mean diameter is 187 kilometers, 189 kilometers. Oh, that says 174 kilometers. Slight difference between, I suppose there's different measurements for different things. Oh, it's an ellipsoid type. So it's about 213 kilometers along, I suppose, the major axis, and then 100, is that 100 and, hold on a second, 160 kilometers around there. So we've gone over to Daphne. Now, let's have a look. So I think there are some objects we can look at here to see if we could identify this. Let me switch this over so we can see. There are 2 stars there, and 2 stars here and here. So those 2 stars are that, and that's 2 stars there, and then there's a double star just there, which is really hard to see. If I better click in a bit. If I come in, you'll see that there are 2. There's a little double star right there. Sorry, I can't see what you're seeing. A little double star there, and then there's these 2, and I think that there is 41 Daphne. But just like the other one, what we do is I will take a 4-second exposure. I just took that off because I wanted to. Let's go back up to auto so we can take it. So we'll take that off there. I'm going to do a snapshot. Oh, it's going to go into the wrong one. Let's do it again. 41. Daphne, is it? Yes, 41 Daphne. Let's do a snapshot of that. That's good. Let's go into that folder. Let's grab hold of that fix file we've just created. Head over to the desktop and we're going to paste that in. Let's bring up ASTAP again, which has still got our PANSTARRS in it, and let's load up Daphne. Let's solve the image. Plate solve, done. And let's annotate with Astro. Oh, there it is straight away. So it was. So we have here, we have these, once this star here is this star here. Got two new windows in. So that star down there is that star there. And Daphne is directly above. So that's 41 Daphne, right there. Distance, what do we say it was? 100, no it wasn't, sorry, 318 million kilometres. Quite a way, 2.1 astronomical units, twice the distance from the Earth to, excuse me, the Sun. That's great fun. I quite enjoy that. No, that's good. Let's go do something else. Yeah. So that's Daphne done. We've finished with Daphne. There's more up there. 3,102 Croc. Oh no, hold on. So this is quite interesting. Before we move on, because is this little one? Right, so this one's 1608. So he's a magnitude 16. Now, yesterday I was looking at nebula that were 17.8 and so on, so it's well within our range. The problem will be is how to identify this as I did before. I think it's going to be quite difficult, in fact, to try and, so that, right, so these, there's two stars that way and two stars over here. They're making a bit of a, they're kind of going out like this. And that's them there, which places our asteroid somewhere. There's another bright star there. Is it that? Have we been in? Do you know it could be? I reckon it could be that little star. That little light right there. But again, we don't need to. This is 3102. 3102 Croc. Let's take a snapshot of it. Again, a 4-second snapshot. Let's copy it across. Last asteroid, I promise. It was just I just thought it was quite fun. Just Crocs as well. Yeah, let's get ASTAP back. Still got Daphne there. And let's open up 3102 Croc. Let's solve the image. And let's annotate. Oh, yeah, there it is. And there is 3102 Croc. What I'm going to do is actually, if I just pin that on top. I can. Oh, was I pinned on top already? That's most probably what it was, wasn't it? Yeah. No, that doesn't sound the right side. Can I not pin this one for some reason? Apparently not. It's stopping me from doing it. Let's just zoom in a bit. Oh, I can see it. Is this one here. It's the one that we thought it was. So if I bring that back, that star there is that star there. A second, sorry. So that star there is that star there. And this star here is not a star, but it is 3102 Croc. And there's a little, and the little star that you see here, just directly above it, we scream it a bit more, there we go, you see there is a star there that you can just about make it out here. It's coming in and out of view just above 3102 Croc, which is at a distance of going 200 million kilometers, but that's a magnitude 16. I doubt very much there'll be anything on. Oh, there is in Wikipedia. Let's have a look. Oh, it was discovered in 1981. 3102 Croc. Oh, it's a near-Earth. It's a near-Earth object. It's NEO. Wow. It has an orbital period of 3.15 years and dimensions, wow, 1.48 kilometers. So it has a minimum. So the Earth's minimal orbital intersection distance is 71 lunar distances. So we didn't know that. It's 1.6 kilometers in diameter. And so it's a near-Earth object. That's one is it Amor group. So they're a group of near-Earth asteroids. The orbital is close to but greater than the orbit of the Earth, with most Amors crossing the orbit of Mars. Wow, we've got a NEO. Well, that was good. So we seem to have found an object that comes within the minimum distance, which is quite nice, 71 lunar diameters, which I suppose astronomically is quite small, but considering it's 1.6 kilometers in size, you wouldn't really want that hitting anywhere or coming anywhere near us, I suppose. But there you go, so we've identified that again. So that's the end of the asteroids, I think. Let's come back out. Let's just do an auto and come back out. Oh, lucky I saw that one there. But I think that's why, I mean, that's the great thing about EAA, is that, you know, you just go wherever you want. We're not on a schedule or anything. We're just going to have a little look around. How's the time going? So we've been doing this for 29 minutes. We're not going to do it too much today. Let's head down. So we looked at the wild duck cluster. Where are we? Are we in the south yet? We are. I think what we'd do first of all. Oh, now we've got loads of asteroids. No, I promised we're not going to go to another asteroid. We might go to the patchy unnamed cloud, which I love. I think we should go and see the patchy unnamed cloud one day. Let's just go to the Omega Nebula again, because that was quite stunning yesterday. I can't remember where I put it. Oh, there it is. So let's go to the Omega Nebula. Let's sleep. We're doing 4 seconds, that's too much. Let's cut it down to 2. SharpCap's got it's got these kind of quick picks up here, and I was wondering if there's a way of me setting what the quick picks are, because I don't want 15 minutes. No. In fact, I don't want 60 seconds, to be quite honest, but there might be some seconds in between that might be nice to see. Right, we've arrived, and as you see straight away in a 2-second in a 2-second view, we have our nebula Omega or Omega, also known as the Swan Nebula, the Horseshoe Nebula, the Checkmark Nebula, and the Lobster Nebula. Okay. We believe you Stellarium, that's what everyone calls it. So we're at M17. Let's we moved a lot then. We're still moving upwards. Now we are quite low. We are at an altitude of 22 degrees, which is, funny enough, exactly the same altitude we were at last night as well. Sorry, cup of tea time. Yeah. I don't know whether it's worth doing a little... No. Let's go into... we were doing 10 seconds last night, weren't we? Let's do 10 seconds again, because I pressed the button and got away from 10 seconds, and let's go into observe mode and see what we can see. Filters most probably fail. We'll reset this in a second once I've figured out what my... Yeah, okay, it's much higher. I think we might need a little bit of a tweak. But there we go, straight into the Omega Nebula. Let's get another frame. Yeah, that started to smooth it almost straight away. Let's move the red up towards where the green is. Let's move the blue up a bit more as well. Kind of balance it up a bit. I think we need some more red. I mean, our mid-levels are terrible. Let's just do an auto one like that. There you go. Stretch it a little bit like this. Stretch it a little bit up. Oh, wow. Oh, the brightness. Oh, you can't see. Let me move myself. Look, the brightness has gone down. We've got something coming across. Just another upturn. We are in the south. We are where a lovely dome of light is appearing. Oh, we're back again. Oh, we got much better. I wonder if we started doing this in the middle of a cloud coming across, or... There you go. And what I'm going to do as well is I'm going to boost the colour a bit. I don't think we were doing it maybe as much justice as we could. Just zoom in a little bit. Let's make that one the same. We've got to flip it. So we have these dark lanes. Let's come in a bit closer. Got these dark lanes just running through it. And then this bright section here. That's what we were looking at last night. Very Very nice. That's 110, so that's 11 frames of stacked. Just come back out again. Not too far, we're at 83% we're zoomed in right now. Oh, I keep on rotating it for some reason. There you go. Get a bit more of a one-to-one view. So we're down in Sagittarius. Oh, the distance. What was the distance? 5,000. Well, it's more, plus or minus 499 light years. 500 light years. Okay, so 5,499. It's right, put in the middle of 6 or 4, or 6 or 5, doesn't it? So. Another little brightness dip. So let me just move myself again. So we had that was our first brightness dip, and then so this is our first brightness dip here, and then we had another little one here, and we got another. Was that just? So we go to the log, we can see what it is. No, that's where the stars are a bit bloaty. So it's 3 minutes. I must admit, I hadn't really looked. I mean, I have looked at the Omega or the Omega Nebula, but when I did it visually, I didn't see this. It was more grey. I remember. A lot of things are. I just find it very. I just find it amazing still. What we can. Oh no, I've gone. I'm messing up not big time there. I don't think I've got any enhancements on. We could try our famous Wiener deconvolution. What do you reckon? It darkens it, doesn't it? Which is interesting, but does it bring out any more? Does it allow us to see more? Hard to say. I can see there's a lot of noise here, but we've only had 24 stacks, 24 frames so far on our stack. If I come out a bit more. Oh wow. So we can see these green bands here. Now we have got two things going on here. Obviously we are in the south. We're at azimuth 172. So we are getting field rotation. Worst place for it. So that's what, but obviously SharpCap can correct for that because we don't get too much over 10 seconds. Actually, if I run my little, I have a little script down here, and it will hopefully. No, you're not going to tell me. Oh, is it? It's gone over here. No, is it not? Oh, that's the first thing that's done that. There you go. So maximum exposure. So if I allow, I think I'm allowing like 2 or 3. I will say I will accept 2 or 3 pixel movement in the corners or something, and that will take a maximum exposure of 34 seconds. So the rotation is currently 10.3 arc seconds per second. I'm not sure that all adds up, thinking about it, but there you go. Anyway, so it says 34 seconds. So we're doing 10. We haven't been above 10. But let's pull that down so we can see more. We're at 45%. Let's auto it. The auto is 45%. Let's go back to see what we're doing here. So we're coming with 5 minutes 30. We've been on it now. I'd like to spend a little bit more time because I'd like to see if I can bring out even more detail. Let me zoom my... Let's see if I can balance it just a little bit. I notice the colours shift around a bit. Blue has disappeared. You right, dog? Sorry, the dog's here again. If I boost the colour. Oh, I've gone too blue, haven't I? There you go. Wow. I'm not going too far here, but I'm just going to go for broke. Yeah, that's horrible. Yeah. I can't see any more, but I can see definitely a lot more noise. And let's balance it up a bit. I think we'll come in a bit because we don't really want to see the green. There you go. So we've got nebulosity up over here, which is the same as the nebulosity we saw yesterday over here. I'm a bit orange, so I most probably haven't got it perfectly correct, but take the colour down a little bit more maybe. Oops, I think I took the colour back up again, but there we go. Not have it so glary. Well, there we go, that's 7 minutes, so that's 42 frames have been stacked so far, so I'm going to save exactly as seen on that one, because that's quite nice. Quite a nice image. I was amazed last night what I saw, so I thought we better come back and take another look. You saw the Eagle Nebula. Okay, I did promise no asteroids, but this is an interesting one. Look, we've got the Black Swan cluster here, M18. So there's going to be tons and tons of stars. So how are we going to possibly find out where our asteroid's gone? Let's pause that a second. Save exactly as seen. We're going to go to M18. Let me just add that as a new object so that we've got it in our observing list. The best one to do, actually. There we go, Black Swan. I'll change it to Black Swan. Let's come out of here, go back into fine mode. 2 seconds would be perfect, most probably. And let's slew to M18. Which is a open cluster, I take it. Yes, an open star cluster, so it's always good to see. Let's stretch the image, and there it is. That's our cluster of stars there. And somewhere in there is 3197 Weissman. In fact, somewhere over here, apparently. Let's up our image to 4 seconds, and let's get rid of the reticle. Done. think we're still moving upwards. Now, on this one, I'm not even sure. I think it's somewhere there. It's somewhere there. I'm going to observe mode. I'm going to stat this, I think. I'll take off zoom a second so we can see what we're doing. Or at 4 seconds. No, let's increase that to 8 seconds and clear. I'm going to turn off the old stretch, display stretch rather than the stretch. Hello, are we now? I'm still at 22 degrees. Okay, I'll give it a little bit of leeway then. So 8 seconds. Actually, let's do an automatic one. See what we can see. Yeah, let's see if we can reduce the noise a little bit. Colour, just up to 1 or something, I expect. Let's bring down the red a little bit. It's coming down nicely anyway, actually, to be honest. And the blue. It's 6 frames, 48 seconds. Right. I'm going to save a 16-bit stack, which will give me a FITS file. Very big FITS file. What am I doing? Well, I don't think I can do that. Hold on a second. I want to copy it. There we go. So I'll copy that file. And I'll take it across again to where we need it, which is on the desktop computer. It's a nice little open cluster. Distance 4,893 light years. Let's just get ASTAP back up while we're waiting and see if we can find 3197 Weissman. That one there, I think it was the most recent. Let's solve it. There we go. And let's see if we can see our asteroid. And we can. Oh, haha. Yes, so there is 3197 Weissman right there. The question is, where? There's the two, that one there. Oh, okay, I got it now, I think. So those 3 stars there are kind of what are these stars here. So those 3 stars lining up there are those 3 stars lining up there. And then there's this little cluster of like 3 stars here, and that's there. And if I come down from there, I've got 1, 2, a brighter one that is, isn't it? Yeah, and then off to the side is Weissman, right reckon if I zoom in on here, you will see that, I hope you'll see anyway. So that star there is, so that star there is that star there, I take it. That star there is that star there. That star there is that star there, which means Weissman is so hard, isn't it? It's very hard to tell. I think that, so I reckon that's Weissman there. Is it? You see, this is where it'd be so good if SharpCap had, in its deep space annotation, it also did asteroid annotation as well. I need to spend a bit more, I can see those are the 3 stars there, aren't they? 3 stars there. You come down to the 2 and you go across to the 1. Yeah, it's there. That is 3197 Weissman, which we have to find it now, because even getting it to work on the, it's really trying not to do it. But shall we go for our trusty Wikipedia and try 3197 Weissman? Yeah, I love Wikipedia here. Not too much information about it. So it was discovered in January 1981, and it's 19 kilometers. And if I go to JPL, yeah, it's 19 kilometers. It has a, that was the data arc since it's been discovered. So last observed on the 15th of May 2022. Sorry, I just went to the JPL small body database and it's got a load of information there. Diameter 18 kilometers, rotation period 6.1 hours. Yeah, nice. Anyway, so I think that showed it that was very useful in figuring out what was going on there, because I don't think we would have spotted it without the help of our ASTAP. So goodbye. Let's go back out now and let's take an observe look at our cluster that we've got. A nice cluster in our galaxy. Oh, I'm ruining it for you again, I think, maybe, but there you go. Lots of field rotation. I really should just, let's do that now. Oh. I have no idea. So this is a star cloud, I take it. The Small Sagittarius Cloud. M25's over here. What have we got over here? M23. The Red Spider Nebula. Do you know, I'm quite tempted just to have a little poke around in here. I have no idea what we'd see. Let's save that as seen. And let's go back into our find mode again. We'll take our down to 2 seconds. And what we're going to do is I'm going to say slew to the center of the screen. So this is not M18. This is the Small Sagittarius Cloud. just going to put cloud. Because we're not sure what it is. It could be unpatchy object or something, I don't know. I'm going to put this up to 10 seconds. And we're going to go into observe mode. I'm just going to see, because it looks quite interesting, but whether we can see any... Ooh, look at that. That's definitely a dark nebula there, isn't it? And possibly one over here. Let's go into our... we've got DSS view gone. Where's that gone? Oh, look at that. These are... If I zoom in, there's definitely a dark galaxy right here. A dark galaxy, I'm talking about. A dark nebula right there, and it looks like another dark nebula right here. I think this is a job for SharpCap. We'll just wait for the dithering to finish. I think this is a job for the SharpCap deep sky annotation. Let's see if it's got any dark. No deep sky catalogues are in the view. So there's 3 objects are nearby. Planetary nebulas, open clusters, and association with stars. Oh, that's a bit disappointing. So we haven't got a glow, but that's definitely a dark nebula, I'd say. I should really use the shift button a bit more, shouldn't I? I might just come out just a little bit so for that. Just want to smooth it off a bit. Go a bit further. Let's try an enhancement. Has that helped? I think it's smoothed it a bit, but in fact, now I've smoothed it on, I'll probably be able to bring it up a bit more. There we go. So there we go. We seem to have found a dark nebula, which I think is quite interesting. So in fact, I think we can... Let's turn off DSS a second. Sorry, I don't know what's going on with this. Oh. No, this won't help me. I have a feeling we need Aladdin or something like that to help us out on finding out what these dark nebula are called, if they're called anything, of course. But that's a new one, a dark nebula down in Sagittarius. To be honest, I think that's a good place to stop. We've looked at asteroids, we've looked at how we can plate solve and find out where they are on our screens. We've looked at a comet. We've looked at some emission nebula and clusters, and now we've finished off with 3-minute-30 stack of these 2 dark nebula, which are deep down in the Sagittarius small cloud. It says Small Sagittarius Star Cloud down here. So that's really good. So I think